F2A 1000, F2B 1000, F2C 1000, F2B 1000, F2A 1000, F2E is E2A, AC, and C, D, E2B 1000, E2C 1000, E2D, E2F 1000, E2E 1000, Okay, now let's complete.
So going A to C, then C to F, C to F. Then F to E. So you have reached destination.
So A to C and then C to F, A to C, then C to F, then F to E. This one. So this right. Correct.
Yeah.
Say it.
So 9 plus 2, 11, 11 plus 9, 20. Right?
Right.
So now you got it.
Right.
Right? It's clear now?
So is it clear?
Yes, sir.
But once again I will repeat, this kind of network, right? This kind of network you will not get. Okay. So you need to develop cluster of network. You have to develop the cluster of network. From that cluster of network, you have to build this matrix. So with that cluster, we'll do that case study when we start our machine learning, one of the machine learning algorithm, which is cluster analysis. At that time, we will apply that. Okay, so we'll move to the transshipment problem. Is any question? If any questions are there, we will discuss. Otherwise, we'll move to transshipment problem.
Yeah, we'll move to the transshipment.
See my screen?
Yes, Krish.
So yesterday we have discussed where is outflow, where is the inflow, and where is the outflow inflow. Right? So I'll repeat it once again. So at F1 and F2, they are supply points. C1, C2, C3, they are the demand points, means customers. So F1 is going to supply, F2 is going to supply, C1 is going to, C2 is going to receive the product, C3 is going to receive the product. Is it clear? What is the role of a stakeholder F1, F2, and what is the role of stakeholder C1, C2, C3?
Yes,
And
Krish.
T1 and T2, their job is to do the resupplying, repack. So what they will do, they will receive the products from F1 and F2. Like T1 will receive the products from F1 and F2, and T2 will receive the products from F1, and they further forward it to C1 and C2. In this particular network, they're not anything. They're not stocking anything. They're just receiving, rescuffling and repacking and dispatching it to the customers. So at transshipment points, there is in and out, both are happening. Means they're receiving in and they're dispatching out. At transshipment points, they're receiving in and dispatching out. Like T1 and T2, they're receiving in and dispatching out. And whatever they're receiving, they're dispatching. They're not saving or stocking anything. So the out minus in will be equal to 0. The out minus in will be equal to 0 at transshipment point T1 and T2. And F1, there is no in, only out. So out minus in is 950, 750. Minus in at T1, T2 is 0 and 0. And at C1, C2, 3C, the out minus in is minus 200, minus 500, and minus 1000. Because there is no out here. Yesterday we have seen this thing. Okay. Now, what we are doing is our objective is to minimize the cost per kilometer. Our objective is to minimize the cost of travel in such a way that we meet the demand of the customers. The objective is this is objective to meet the demand of the customers by minimizing the cost of transportation. So here I'm going to build. This is a matrix which we have. This is cost matrix, transportation cost matrix. Right? And this is the assignment matrix. How much factory 1 has to be assigned? How much factory 2 has to be assigned? How much the transshipment 1 has to be assigned? How much means how much load? Okay, how much load or how much responsibility of supply the factory 1 has to be assigned in such a way that it reaches C1, C2, C3 at minimal transportation cost. How much supply responsibility to be assigned to factory 2 in a way it reaches C1, C2, C3 and the total transportation cost is minimized. How much the factory 1 has to ship it to the transshipment point 1 and 2 in such a way that we meet the demand of customers C1, C2, C3 and we achieve this demand fulfillment at a minimum cost. This is what the objective. Okay, so I'll make all of them blank. If you put blank also is okay. If you don't put 0 also it's okay because Excel treats blank as 0 only. Okay, is it clear? What did you achieve? Yes, Priyanka, what are we trying to achieve?
To meet the demand. Yes, Krish.
So what is it? What is the objective? Can you?
Can you slow down your screen just a little bit? Down, 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 down. Yes. To meet the demand of the customers by minimizing the cost of the transportation. This is the objective.
Is it clear, right?
Yeah, right.
Now, what is the constraint? So what is the constraint here? The constraint is outflow and inflow. Constraint will be outflow and inflow. So what is outflow at factory 1? What is outflow at factory 1? 950 units. What is outflow at factory 1? What is the inflow at factory 1? 0. There's no inflow happening in factory 1, right? Nobody is giving the product to factory 1. Nobody is giving the product to factory 2. Factory 2 is manufacturing and dispatching it forward. So there is no info happening at factory 1 and factory 2. That's why we have done the calculations. Now, what is outflow at factory 2? That is 750 units. What is the inflow at factory 2? 0. What is the inflow at what is the inflow at transshipment 1? That is 850. What is the outflow at factory at transshipment point 1? Again, it is 850 units. Whatever transshipment point is receiving, it is dispatching it forward. What is the outflow at transshipment point 2? It's 850 units. And what is the inflow? It's 850 units. Whatever is receiving is dispatching it forward. What is the inflow? What is the outflow at C1? There is no outflow at C1. There is no outflow at C1, C2, and C3 because they are customer points. They are not dispatching it forward as per this network. They are only receiving as per this network. What they are receiving at C1, the receipt is how much? 200. At C2, the receipt is how much? 100. At C3, the receipt is how much? 1000. 200, 500, and 1. So these are the inflows at nodes, and this is outflow at each node. Any questions here?
So Krish, this outflow is 950.
This outflow is not. This outflow is not 950. This outflow is at factory 1. This is at factory 1. At factory 1, the outflow is 9. This is how you have to read it. At factory 1, the outflow is 950. At factory 1, the inflow is 0. At factory 2, the outflow is 750. At factory 2, the inflow is 0. Like this, you have to read. At the transshipment 1, the inflow is 850. And transshipment point 1, the outflow is also 850. Because it has to forward everything, whatever it is receiving. At transshipment point 2, the inflow is 850 and outflow is also 850 because whatever the shipment point 2 is receiving, it has to dispatch it forward. right? At customer point 1, there is no outflow. As per this network, customer is only receiving here. There is no outflow happening here. Only customer receiving. Means receiving means inflow of 200. Same with customer 2, there is no outflow, only receiving 500. At customer 3, there is no outflow, only receiving 1000. So this is a major point. If you are when we define our constraints, this is a major. This is what we have defined constraints. This is our constraint. Means F1 will not receive anything. F1 will only dispatch. F2 will not receive anything. F2 will only dispatch. T1 will receive 850 and will dispatch 850. T2 will receive 850 and will dispatch 850. C1 will not dispatch anything. C1 will receive everything. C2 will not dispatch anything. C2 will only receive. C3 will not dispatch anything. C3 will only receive. That is what we have decided. Constraints. Is this point clear? Because this point has to be clear. If you want to define the problem, right? we are doing the formulations here, right? Most important thing is formulation. Doing the formulations correctly, then rest machine will take care of everything. Like we have open solver. Open solver will take care of everything, right? Now, what I want to, whatever assignments are done, those assignments have to follow this rates. The sum of assignments at F1, right? Sum of assignments at F1 or F2 or T1 or T2 should be equal to this inflow. And sum of assignments at outflow it should be as per this outflow. So whatever assignments we'll do over here, right? Zero, of course, there is a formula here. Sum of assignments means this is sum of assignments. Taking the formula here. Double click. So this is assignments. Whatever assignments the solver will do us or machine will do for us, that has to be equal to this inflow value. Whatever assignments are done over here, that has to be equal to this outflow values. That's the constraint. So we have to define the assignments and we have to calculate the sum of assignments, and those assignments has to be equal to outflow and inflows which we have defined. For that, we cannot measure outflow separately, we cannot measure inflow separately. So we have to derive a formula. Outflow minus inflow. This is 950 minus 0. This is 750 minus this. This is 850 minus the third one. This is 850 minus the fourth one. This is outflow minus this. This is outflow minus this. This is outflow minus this. What we want, the sum of outflows should be equal to this, and the net outflow minus inflow should be equal to this. So, I mean, right? This is what we are finding, and we are saying that whatever is out minus. So we are. This is constraint for flow. This is constraint for inflow, right? And what you're saying that outflow minus inflow. The outflow minus inflow, right? We have to find this outflow minus inflow here. One more bracket here. So outflow minus inflow. This is our out minus in. This is 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 out minus 1, 2, 3, 4, 5. Last one's out minus in. I'll just check the formula once again. Double click. Perfect. 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 And this is perfect. This is out minus in. Okay, this is outflow minus inflow. This is my constraint. Okay, so I have defined the constraint. Now I have defined my objective. Some product of this matrix and this matrix. Has to be minimum. Go to model now. To minimize this, my variable cells are this. Here we need assignments. Add so these variable cells has to be binary, let's say binary. Let's add this. Let's put this as an integer. Third constraint is this sum in has to be equal to these values. This sum out has to be equal to these values. And we have to add one more constraint. That is our out minus in has to be equal to this. So just check what are the constraints I have defined. First constraint is my variable cell has to be binary. Is it clear? The first constraint.
Yes, Kush.
The variable cells has to be integer. Is this clear?
Yes.
The
Binary.
binary and integer, right? And what I want is my sum of the inflow has to be equal to this. Whatever sum of inflow the assignment, so solver will do the assignment. So what I want is sum of the assignment, if what else assignments are done. So on that, sum of in has to be equal to 0, 0, 850, 850, 200, 500, 1000. Now, whatever assignments solver will do, right? I want sum of out. I want sum of out. What is the sum of out here? X. Where is X? Yeah. Sum of out, right? Sum of out is equal to, yeah. So X is equal to Y. Okay. So all these outs, whatever I receive, the sum that has equal to this outflow. 950, 750, 850, 850. And the last one is the out minus in. The out minus in has to be equal to these values. So I'll just go to simplex LP and solve this problem. Let's see whether we get the solution or not. Oh my god, I made a mistake here. So this is not binary. We need values there. We don't want binary, we want 0. We want values. How much is to be assigned? I'm sorry for that. We don't need binary values over here. We need the values, means we shall be assigned 200 units, shall be assigned 400 units, or shall be assigned 600 units. That is what we need here. We don't want binary. Okay, we found a solution. Let's see what is the solution here. So F1 is delivering to FT1, that is 850 units. F1 is delivering to T2, that is 100 units. So what is total capacity of F1? 950. You can look at outflow is 950. 950. Total capacity of F1 is how much? 850 plus 100, 950. And the assignment is also happening the same way. F1 is delivering to transshipment point 1, 850 units. And maximum capacity of T1 is how much? 850. T1 can receive only 850 units. So if all those 850 units are coming to T1 via F1. and the capacity of T2 is 850. So T2 is getting the deliveries from F1 100 units and F2 750 units. And look at here, there is no inflow at F1. There is no inflow at F1. There is no inflow at F2. This is also met. Only F1 is releasing the material. F1 and F2 is only supplying the materials. F1 and F2 are not receiving the materials. So F1 is delivering 850 units to T1 and F1 is delivering 100 units to T2, and the total supply capacity of F1 and F1 is 950. That is what we got here. Outflow is target, the constraint was 950. So that is what it is matching. F2, the capacity of F2 is how much? 750 units. Look at here. So F2 is delivering all its 750 units to T2. So the outflow capacity is 750, and we are matching our constraint is also matching here. And here there is no inflow for F1 and F2. That is what we wanted. So this condition has matched. Now look at T1. T1 has to deliver 850 units. T1 has to deliver 850 units. It is delivering to C3. So what is capacity of C3? C3 is 1000. So C3 wants 1000. So 850 is going from C3. 850 is going to C3 via T1. Now T2. T2 is delivering 200 units to C1, 500 units to C2, and 150 units to C3. What is capacity of C1? 200. Right? It is matching here. Look at the inflow is 200. What is it? What is the total inflow we can do into C2? What is demand is? Inflow is what is demand of C2? 500 units. We are giving 500 units, and this going to C2 via T2. And the balance 150 units, the balance 150 units of C3 is going from T2. So we are seeing that all our constraints are mapping. There is no inflow at F1, no inflow at F2. There is inflow of 850 units at T1, and there is outflow of 850 units at T1. So net inflow is 0. Net outflow and inflow is 0. There is a net inflow of 850 units at T2. Net outflow of 850 units at T2. So and outflow versus inflow is 0. Matching constraints. C1 cannot dispatch. C1, C3, they cannot dispatch. There is no outflow. C1, C2, C3, there can be only inflow. Means they can only receive. So C1 has to receive 200 units. C2 has to receive 500 units. That's why it's called a diagram. C3 has to receive 1000 units. This is what is, and the objective is we are getting the minimized cost. The minimized cost is 32,400 US dollars. So most important thing is now understand what is the role of a node. The role of node is to receive or dispatch, or receive and dispatch both. So F1 and F2 is dispatching nodes. C1, C2, C3 are receiving nodes, and T1 and T2 are receiving as well as dispatching nodes. Second question is how much they receive, how much they dispatch. Second question. And third is what is the cost per unit per kilometer? The cost per unit per kilometer. This is cost per unit per kilometer. Whatever value we have here, right? This is cost per unit per kilometer. This is 10 US dollar per piece per kilometer. 12 US dollar per piece per kilometer. 8 US dollar per piece per kilometer. Now we have to multiply this units into cost to get per kilometer to get this particular objective. That is 32,000. 400 per kilometer for total volume to dispatch to C1, C2, and C3. This is only per kilometer, okay? It's not the total kilometer, only per kilometer.
Krish, can you upload this sheet on Teams? Just I want to go through.
We'll solve one problem after this.
Okay.
I'll ask you to do that. So please share your screen. So we'll go to your screen and we'll try to solve a new problem. The most important thing is we have to understand what is our the role of a stakeholder. Like we have nodes, factory 1, factory 2, T1, transshipment points 1, transshipment point 2, customer point 1, customer point 2, customer point 3. What are the roles they have? The role of factory 1 is to dispatch the goods, means supply the goods. The role of customer is to receive the goods here as per this network. And the role of transshipment point is to receive from factory and dispatch it to the customer. So based upon that, we will derive our constraints. Yeah, Priyanka, the file is uploaded. Now you can share your screen. We'll solve one more problem.
The new file name is optimization case study.
Yeah, that is one. Just now I uploaded.
Okay.
Just refresh it once again. I think you might be seeing the older file. You have to refresh the Teams. Once you refresh, you'll get the latest version. Shoaib, it is clear, Shoaib, for you?
Yes, sir.
This is how we can reduce your transportation cost. And you can also meet your customer demand. So important point is we are meeting our customer demand. We are sacrificing the customer demand. Means we are actually maintaining our responsiveness. We are maintaining our service level. At the same time, we are reducing the cost. Means the trade-offs of supply chain. The trade-off of supply chain is service level and cost. We are achieving both of them over here. We are achieving our service level, means we are responding to customer with the demand, and as well as we are saving the money. You download, you upload.
I have downloaded, but
This is the previous file, right? Oh, this is the previous file. I think you have to refresh. No, you have to go to Teams. Not here, go to Teams. Not chat, go to Teams. Teams. Go to files. Go to files. Now you have to go to modified. Go to modified. Yeah, newer to older. Now look at here. What is the latest date? 2 minutes ago. Yeah, this is the file you have to download.
optimization transshipment problem. Okay, I downloaded this one.
Okay, there is a file. Just look at, if you have any questions, you can ask. Look at the constraint, go to the model, solver model, look at the model, look at the constraint, look at the objective, how we have developed this formulation. Look at the diagram also. Look at the diagram.
Mm-hmm. Mm-hmm. Transportation.